We're going to Google IOBNT taxonomy. It's the Internet of Bio Nano Things taxonomy. And we're going to click on the images. What do you see here? Patient skeleton, nano devices, nano network cloud, biocyber interface, the nano gateway, your local area network link, access point, wide area network link, internet service provider cloud, and you have the monitoring computer and the medical personnel. This is a schematic representation of the Internet of Bio Nano Things. Here, we have an illustrative network architecture for the Internet of Bio Nano Things. You have your heart, network 1, left kidney, network 2, right kidney, network 3, stomach, network 4. Here is the biocyber interface, mini transceiver, the internet, and your healthcare provider. Up here, it says nano devices and nanoparticles. And as you can see on the image, the nano devices are in the heart, kidneys, and stomach, and the nanoparticles are in the bloodstream. And over here, they're fighting COVID-19 and future pandemics with the Internet of Things. Here's Hacker Noon. What the fuck is Internet of Bio Nano Things, and how secure is it? Let's click on the link. Internet of Bio Nano Things, IOBNT, is a domain where biochemical processes inside the human body communicate the cyber world of the Internet. IOBNT paradigm stems from synthetic biology and nanotechnology tools and enables the engineering of biological embedded computing devices called nanomachines. Nanomachines are a powerful and functional man-made tiny devices. The functionality of these devices is inspired by the behavior of atomic and molecular structures composed of nanoscale components. They not only function as computers, but also establish connections with the environment, human body, to detect a physical quantity as living organisms. Communication inside the human body is as old as the existence of mankind. Indeed, the human body is a large-scale, heterogeneous communication network of nanonetworks, as it is composed of billions of interacting nanomachines, like your cells, whose functionalities primarily depend on nanoscale molecular communications. Hence, the vital conditions of the human body directly depend on the performance, reliability, and continuous functioning of intra-body molecular nanonetworks. What have we been talking about on the channel? Our bodies naturally have molecular communications. This is how our bodies function. And this is how they're playing with us and controlling us under our skin. Here's the architecture of the Internet of Bio Nano Things, and this is directly from the IEEE Communications magazine. Here's bacteria-based nanomachines. I will leave the links in the description for those who want to keep reading, but for now let's go over here to ResearchGate, and we're going to read Nano Networks Communication Architecture, Modeling and Functions. This was released in July 2018, before the pandemic. Nano network is a communication network at the nanoscale between nano devices. Nano devices face certain challenges and functionalities because of limitations in their processing capabilities and power management. Hence, these devices are expected to perform simple tasks which require different and novel approaches. In order to exploit different functionalities of nanomachines, We need to manage and control a set of nano devices in a full nano network using an appropriate architecture. This step will enable unrivaled applications in the biomedical, environmental, and industrial fields. By the arrival of Internet of Things, the use of the Internet has transformed, where various types of objects, sensors, and devices can interact, making our future networks connect nearly everything from traditional network devices to people. From traditional network devices to people. Hello, people. In this paper, we provide a unified architectural model of nano network communication with a layered approach combining software-defined network, network function virtualization, and Internet of Things technologies, and present how this combination can help in nano networks context. Consequently, we propose a set of functions and use cases that can be implemented by nano devices and discuss the significant challenges in implementing these functions with nanotechnology paradigm and the open research issues that need to be addressed. Let's click on these images. Software-defined network architecture. You have the infrastructure layer, you have the control layer, and the application layer. Here is the set of functions of nano networks. Open Flow Protocol. This is an architectural model of nano networks. You have the nano network layer, software-defined network layer, the Internet of Things layer, fog computing layer, and the network function virtualization layer. Here you see nano machines, micro nano gateway, wireless access point, software-defined network switches, open flow controller, device management server, fog computing node, object name service server, server running virtualization software, and here is the cloud. And we're back to the image that we started with. Now let's go over here. This is a network architecture for intra-body nano networks with nano sensors. The red squares are nano sensors. The blue squares are the sync nodes. And they are everywhere. They're in your brain, in your heart, in your lungs, in your muscles, in your bones, in your tissues. Look over here. It's all under your skin, in your fat, in your blood. This is the multipath channel model. This is the skin layer. This is the fat layer. And this is the blood layer. And these are your sensors. Let's click on it and give it a read. In this work, the author has evaluated the propagation of electromagnetic waves inside the human tissue, such as blood, skin, and fat, for single path and multipath layers, according to nanosensor transmit power calculations. In particular, the propagation characteristics of the intra-body nano network communication channel are calculated using a theoretical approach. The analysis in this paper provides an evaluation related to the path loss, bit error rate, signal-to-noise ratio, and channel capacity. The model is evaluated for each single path effect and multipath effect. The effects of human tissue for each blood, skin, and fat for single path effect and multipath are included in the analysis. The model frequency range is chosen from 0.01 to 1.5 terahertz frequencies, which are ideal for designing nanosensors antennae and using terahertz range for communication. This paper will also guide the other researchers who are working on the electromagnetic radiation performance of intra-body nano network and nanosensors designed at the terahertz range.